The early history of radio is the history of technology that produced radio instruments that use radio waves. Within the timeline of radio, many people contributed theory and inventions in what became radio. Radio development began as wireless telegraphy. Later radio history increasingly involves matters of broadcasting summary. Invention. The idea of wireless communication predates the discovery of radio, with experiments in wireless telegraphy, via inductive and capacitive induction and transmission through the ground, water, and even train tracks from the 1830s on. James Clerk Maxwell showed in theoretical and mathematical form in 1864 that electromagnetic waves could propagate through free space. It is likely that the first intentional transmission of a signal by means of electromagnetic waves was performed in an experiment by David Edward Hughes around 1880, although this was considered to be induction at the time. In 1888, Heinrich Rudolf Hertz was able to conclusively prove transmitted airborne electromagnetic waves in an experiment confirming Maxwell's theory of electromagnetism. After the discovery of these Hertzian waves, many scientists and inventors experimented with wireless transmission, some trying to develop a system of communication, some not, some intentionally using these new Hertzian waves, some not. Maxwell's theory showing that light and Hertzian electromagnetic waves were the same phenomenon as different wavelengths led Maxwellian scientists, such as John Perry, Frederick Thomas Troughton and Alexander Trotter, to assume they would be analogous to optical signaling, and the Serbian-American engineer Nikola Tesla to consider them relatively useless for communication, since light could not transmit further than line of sight. In 1892, the physicist William Crookes wrote on the possibilities of wireless telegraphy based on Hertzian waves, and in 1893 Tesla proposed a system for transmitting intelligence and wireless power using the Earth as the medium. Others, such as Amos Dolbear, Sir Oliver Lodge, Reginald Fessenden, and Alexander Popov, were involved in the development of components and theory involved with the transmission and reception of airborne electromagnetic waves for their own theoretical work or as a potential means of communication. Over several years, starting in 1894, the Italian inventor Guglielmo Marconi built the first complete, commercially successful wireless telegraphy system based on airborne Hertzian waves. Marconi demonstrated application of radio in military and marine communications and started a company for the development and propagation of radio communication services and equipment. 19th century. The meaning and usage of the word radio has developed in parallel with developments within the field of communications and can be seen to have three distinct phases: electromagnetic waves and experimentation, wireless communication and technical development, and radio broadcasting and commercialization. In a 1864 presentation, published in 1865, James Clerk Maxwell proposed his theories and mathematical proofs on electromagnetism that showed that light and other phenomena were all types of electromagnetic waves propagating through free space. In 1886–88, Heinrich Rudolf Hertz conducted a series of experiments that proved the existence of Maxwell's electromagnetic waves, using a frequency in what would later be called the radio spectrum. Many individuals, inventors, engineers, developers and businessmen, constructed systems based on their own understanding of these and other phenomena, some predating Maxwell and Hertz's discoveries. Thus, wireless telegraphy and radio wave-based systems can be attributed to multiple inventors. Development from a laboratory demonstration to a commercial entity spanned several decades and required the efforts of many practitioners. In 1878, David D. Hughes noticed that sparks could be heard in a telephone receiver when experimenting with his carbon microphone. He developed this carbon-based detector further and eventually could detect signals over a few hundred yards. He demonstrated his discovery to the Royal Society in 1880, but was told it was merely induction, and therefore abandoned further research. Thomas Edison came across the electromagnetic phenomenon while experimenting with a telegraph at Menlo Park. He noted an unexplained transmission effect while experimenting with a telegraph. He referred to this as etheric force in an announcement on November 28, 1875. Elihu Thomson published his findings on Edison's new force, again attributing it to induction, an explanation that Edison accepted. Edison would go on the next year to take out U.S. Although this was not a radio system, the Marconi Company would purchase the rights in 1903 to protect them legally from lawsuits. Hertzian waves. Between 1886 and 1888, Heinrich Rudolf Hertz published the results of his experiments where he was able to transmit electromagnetic waves through the air, proving Maxwell's electromagnetic theory. Early on after their discovery, radio waves were referred to as Hertzian waves. Between 1890 and 1892, physicists such as John Perry, Frederick Thomas Troughton and William Crookes proposed electromagnetic or Hertzian waves as a navigation aid or means of communication, with Crookes writing on the possibilities of wireless telegraphy based on Hertzian waves in 1892. After learning of Hertz demonstrations of wireless transmission, inventor Nikola Tesla began developing his own system based on Hertz and Maxwell's ideas, primarily as a means of wireless lighting and power distribution. Tesla, concluding that Hertz had not demonstrated airborne electromagnetic waves, went on to develop a system based on what he thought was the primary conductor, the Earth. In 1893, demonstrations of his ideas, in St. Louis, Missouri and at the Franklin Institute in Philadelphia, Tesla proposed this wireless power technology could also incorporate a system for the telecommunication of information. In a lecture on the work of Hertz, shortly after his death, Professor Oliver Lodge and Alexander Muirhead demonstrated wireless signaling using Hertzian waves in the lecture theatre of the Oxford University Museum of Natural History on August 14, 1894. During the demonstration, a radio signal was sent from the neighbouring Clarendon Laboratory building, and received by apparatus in the lecture theatre. Building on the work of Lodge, the Indian Bengali physicist Jagadish Chandra Bose ignited gunpowder and rang a bell at a distance using millimeter-range wavelength microwaves in a November 1894 public demonstration at the Town Hall of Kolkata. Bose wrote in a Bengali essay, Adrusia Alyok, the invisible light can easily pass through brick walls, buildings etc. Therefore, messages can be transmitted by means of it without the mediation of wires. Bose's first scientific paper, on polarization of electric rays by double refracting crystals, was communicated to the Asiatic Society of Bengal in May 1895. His second paper was communicated to the Royal Society of London by Lord Rayleigh in October 1895. In December 1895, the London journal The Electrician published Bose's paper on a new electropolariscope. At that time, the word coherer, coined by Lodge, was used in the English-speaking world for Hertzian wave receivers or detectors. The Electrician readily commented on Bose's coherer. The Englishman quoted from The Electrician and commented as follows: should Professor Bose succeed in perfecting and patenting his coherer, we may in time see the whole system of coast lighting throughout the navigable world revolutionized by an Indian Bengali scientist working single-handed in our Presidency College laboratory. Bose planned to perfect his coherer, but never thought of patenting it. In 1895, conducting experiments along the lines of Hertz's research, Alexander Stepanovich Popov built his first radio receiver. which contained a coherer. Further refined as a lightning detector, it was presented to the Russian Physical and Chemical Society on May 7, 1895. A depiction of Popov's lightning detector was printed in the Journal of the Russian Physical and Chemical Society the same year. An earlier description of the device was given by Dmitry Alexandrovich Lakhanoff in July 1895 in the second edition of his course, Fundamentals of Meteorology and Climatology, the first in Russia. Popov's receiver was created on the improved basis of Lodge's receiver, and originally intended for reproduction of its experiments. Marconi. In 1894, the young Italian inventor Guglielmo Marconi began working on the idea of building a commercial wireless telegraphy system based on the use of Hertzian waves, a line of inquiry that he noted other inventors did not seem to be pursuing. Marconi read through the literature and used the ideas of others who were experimenting with radio waves, but did a great deal to develop devices such as portable transmitters and receiver systems that could work over long distances, turning what was essentially a laboratory experiment into a useful communication system. By August 1895, Marconi was field testing his system, but even with improvements he was only able to transmit signals up to 1/2 mile, a distance Oliver Lodge had predicted in 1894 as the maximum transmission distance for radio waves. Marconi raised the height of his antenna and hit upon the idea of grounding his transmitter and receiver. With these improvements, the system was capable of transmitting signals up to 2 miles and over hills. Marconi's experimental apparatus proved to be the first engineering-complete, commercially successful radio transmission system. Marconi's apparatus is also credited for saving the 700 people that survived the tragic Titanic disaster. In 1896, Marconi was awarded British Patent 12039, improvements in transmitting electrical impulses and signals and in apparatus, therefore the first patent ever issued for a Hertzian wave-based wireless telegraphic system. In 1897, he established a radio station on the Isle of Wight, England. Marconi opened his wireless factory in the former Silk Works at Hall Street, Chelmsford, England in 1898, employing around 60 people. Shortly after the 1900s, Marconi held the patent rights for radio. Marconi would go on to win the Nobel Prize in Physics in 1909 and be more successful than any other inventor in his ability to commercialize radio and its associated equipment into a global business. In the U.S., some of his subsequent patented refinements would be overturned in a 1935 court case. 20th century. In 1900, Brazilian priest Roberto Landau de Moura transmitted the human voice wirelessly. According to the newspaper Jornal do Comércio, he conducted his first public experiment on June 3, 1900. In front of journalists and the General Consul of Great Britain, C.P. Lupton, in São Paulo, Brazil, for a distance of approximately 5.0 miles. The points of transmission and reception were Alto de Santana and Paulista Avenue. 1 year after that experiment, he received his first patent from the Brazilian government. It was described as equipment for the purpose of phonetic transmissions through space, land and water elements at a distance with or without the use of wires. 4 months later, knowing that his invention had real value, he left Brazil for the United States with the intent of patenting the machine at the U.S. Patent Office in Washington, D.C. Having few resources, he had to rely on friends to push his project. Despite great difficulty, 3 patents were awarded: the wave transmitter, which is the precursor of today's radio transceiver, the wireless telephone, and the wireless telegraph, both dated November 22, 1904. The next advancement was the vacuum tube detector, invented by Westinghouse engineers. On Christmas Eve 1906, Reginald Fessenden used a synchronous rotary spark transmitter for the first radio program broadcast from Ocean Bluff, Brant Rock, Massachusetts. Ships at sea heard a broadcast that included Fessenden playing O Holy Night on the violin and reading a passage from the Bible. This was, for all intents and purposes, the first transmission of what is now known as amplitude modulation or AM radio. In June 1912, Marconi opened the world's first purpose-built radio factory at New Street Works in Chelmsford, England. The first radio news program was broadcast August 31, 1920 by station 8MK in Detroit, Michigan, which survives today as all-news format station WWJ under ownership of the CBS network. The first college radio station began broadcasting on October 14, 1920 from Union College, Schenectady, New York under the personal call letters of Wendell King, an African-American student at the school. That month 2ADD aired what is believed to be the first public entertainment broadcast in the United States. A series of Thursday night concerts initially heard within a 100-mile radius and later for a 1,000-mile radius. In November 1920, it aired the first broadcast of a sporting event. At 9 p.m. on August 27, 1920, Sociedad Radio Argentina aired a live performance of Richard Wagner's opera Parsifal from the Coliseo Theatre in downtown Buenos Aires. Only about 20 homes in the city had receivers to tune in this radio program. Meanwhile, irregular entertainment broadcasts commenced in 1922 from the Marconi Research Centre at Writtle, England. Sports broadcasting began at this time as well, including the college football on radio broadcast of a 1921 West Virginia vs. Pittsburgh football game. One of the first developments in the early 20th century was that aircraft used commercial AM radio stations for navigation. This continued until the early 1960s when VOR systems became widespread. In the early 1930s, single sideband and frequency modulation were invented by amateur radio operators. By the end of the decade, they were established commercial modes. Radio was used to transmit pictures visible as television as early as the 1920s. Commercial television transmissions started in North America and Europe in the 1940s. In 1947, AT&T commercialized the mobile telephone service. From its start in St. Louis in 1946, AT&T then introduced mobile telephone service to 100 towns and highway corridors by 1948. Mobile telephone service was a rarity with only 5,000 customers placing about 30,000 calls each week. Because only 3 radio channels were available, only 3 customers in any given city could make mobile telephone calls at one time. Mobile telephone service was expensive, costing $15 per month, plus 0.30 to 40 United States cents per local call, equivalent to about $176 United States per month and 3.50 to 4.75 per call in 2012 United States dollars. The Advanced Mobile Phone System analog mobile cell phone system, developed by Bell Labs, was introduced in the Americas in 1978. Gave much more capacity. It was the primary analog mobile phone system in North America through the 1980s and into the 2000s. In 1954, the Regency Company introduced a pocket transistor radio, the TR-1, powered by a standard 22.5V battery. In 1955, the newly formed Sony Company introduced its first transistorized radio. It was small enough to fit in a vest pocket, powered by a small battery. It was durable, because it had no vacuum tubes to burn out. Over the next 20 years, transistors replaced tubes almost completely except for high-power transmitters. By 1963, color television was being broadcast commercially, and the first communication satellite, Telstar, was launched. In the late 1960s, the U.S. long-distance telephone network began to convert to a digital network, employing digital radios for many of its links. In the 1970s, LORAN became the premier radio navigation system. Soon, the U.S. Navy experimented with satellite navigation, culminating in the launch of the Global Positioning System constellation in 1987. In the early 1990s, amateur radio experimenters began to use personal computers with audio cards to process radio signals. In 1994, the U.S. Army and DARPA launched an aggressive, successful project to construct a software-defined radio that can be programmed to be virtually any radio by changing its software program. Digital transmissions began to be applied to broadcasting in the late 1990s.